what machine learning application is, how to build. This is a lot of questions, and in this video I'm going to answer the common queries, and you will see how to build an application in machine learning. So welcome back to my introduction to data science part 3 video. In this session I'm going to explain you about the basic process of building an application in machine learning. Then I will tell you some more about techniques about how to pre-process the data, and in my later on video I will tell you how to build the model and about this data science course. So let's start. So first you need to check your data, whether it's in CSV file or it's in big data, or it is in any other format, or it is in database. So you should need to know what type of file you have. Then you look at your file, then decide what you actually want from them. What will be the outcome of your machine learning model. So this way you the first step is to define your problem. Then you need to pre-process the data. The data always have null values, always have outliers, so and some characters and some strange things. So you need to pre-process the data and prepare your data for model building. This is a very important step. Every data scientist do this thing, otherwise they can't fit the data into the model. The next is you need to spot check the algorithms. You need to run different algorithms on your data, pre-processed data, and see which data will give you better score and less error. Then you need to improve your results by different techniques, and the most important thing is to present your results to the client or to your to the end customer. This is the basic step of building an application in machine learning. So here I have data for predicting house prices, and I have all the details regarding an house, and my end target is to predict the price of the house. So and this is in this I'm using the regression technique, the regression algorithm, to build a machine learning model. And what the regression algorithm is, let me tell you briefly. It's a supervised machine learning algorithm in which it will take all the details of my predictor variables and then will give you the output or a predicted price of the house. Then we will check with the price of the house with the actual price of the house and improvise our model. So let's see the data first. So here is the data. It's in the house train.csv file, and as you can see, it has 1490 rows and 81 columns. These are the column names which you call as variables in data science, and these are the rows. So if you go ahead, you can see there is a column name called sell price. This is our target variable. We will find out the sell price using our model, and you will compare the sell price with this already existing sell price and see how much they are different from each other. When the difference is less, we can say that our model is now ready to go, so that we can fit our model with some unseen data. So So this is the basic outline of this machine learning model. Here we have training data. We will fit the training data to feature extraction. In feature extraction, what we will do, we will take out all the predictor variables and then the target variable. Then we will fit the predictor variables to our machine learning model, which will predict our target price, and we will and here we are comparing the already existing price with the target price, and we will use some machine learning algorithm to enhance our model. Then again we fit the data to enhanced model and check the result until we get a good model. Then we can go ahead and say that our machine learning model is ready for any unstructured data. So let's me quickly go through the pre-processing steps. Let me take you to Jupyter, and here as you can see this Jupyter screen. Here I have imported all the important packages. Then we can go ahead and see. Then we go ahead and import our data. Here I have imported the data and I check the data details using the info method. As I told you, it has 1460 entries, that is 1460 rows, and 81 columns, meaning 81 variables, out of which 79 is predicted variables, because ID is no longer will be used for predicting our sell price, and our target variable is sell price, so we will also take out the sell price from the predictor variable list. Then we just quickly go and do some check on data, whether they have missing values or and then we see that I plot the missing values here. I did my every visual data processing steps with visualization to get the result with less error. So here I can see that the pure QC has more missing values, and then we go ahead and check the distribution of sell price, because my model needs normalized data. So this data is not in a normal form. So just see the sell price distribution. They are not normalized. What normalized data is? It's a plot. Let me show you what normalized data is. This is what normalized data look like. It has mean 0 and standard deviation 1. It is equally distributed around the mean. But if you see our data, it's not at all normalized data. Its distribution is skewed. So we have to do some pre-processing on our target variable before fitting them to the model. Then I check the normality with all the data which I have, the quantitative data, the category data, and while doing the category data I have encoded the category data and removed all the null values, and I check how many categories are there in each categorical variables, so that I just encode them. I did encoding in manually, so I need to check how many categories are there in each category variable. Then after all this checking, I just see which variable has high impact on my target variable. Then I check the correlation among the data and correlation of the data with the sell price, and as you can see that if I go down little head, you can see that this overall quality and neighborhood data, they have high impact on sell price. So with this plot, I can easily select which variables have high impact on my target variable, so that I can remove those variables which has very minimal effect. and then I go ahead and check the relationship among the data with heat map. And as you can see, heat map is very easily readable. It's the maroon side shows positive correlation, blue side negative correlation, and as I go ahead I check, I can see which data is highly related to, is if you see the here my sell price is highly related to qual. If you see, year of build is highly correlated to garage year of build. So this correlation is more important to check before building the model. Then I did some check how they are. I have already done all the encoding. So what I have done, I've converted all the categorical variables to numeric, and then I go ahead and check which data has lot of variation with the sell price. Then finally I built my model choosing the right data. And if I go down, you can see that my y variable distribution is not normalized, so I need to use some logarithm function to normalize the data. So this is how I have done pre-processing on my data so far. In my next video I will tell you how I build a model, and how can you check the errors, and how can we refine our model. Thank you.